Well, let's see how this creature of the rational roots theorem, how it works, and first let's see what it is, though. All right, so here's your polynomial in generalized terms. Remember that big old definition from 4.1? Well, here it is again. But the first term and the last term are not zero. So it's a polynomial of degree 1 or higher where each coefficient is an integer. So the possible rational zeros are of the form P over Q. So rationals, so no irrationals, no like weird square roots or pi or e, they're all rational. So some sort of a fraction. Where P, those are the factors of a sub 0, so the factors of the back number, and Q, those are the factors of the leading coefficient, that a sub n. So example 5, we're just going to practice using the theorem, and then in example 6, we'll actually figure out what the actual zeros are. So in 5, we're just going to list out the possible rational zeros, not the actual, just the possible. So let's figure out what P, the values of P could be and the values of Q. So with P, I'm looking at this back number here, the 6. So what are the factors of 6? Well, that would be 1, 2, 3, and 6. And I left some spaces in there because you could also include the negatives. So those are all the factors of 6. So Q, now you're going to go back and look at the leading coefficients. So the Q would be the factors of 4. So the factors of 4, plus or minus 1, plus or minus 2, and plus or minus 4. So then your possible zeros, once you've created this list, you're going to follow the format that we just described in the box. It's any factors or any zeros that are of the form P over Q. So it's any combination of these numbers over these numbers. So any of the numbers in P over the numbers of Q. So what I do is I just kind of take them one at a time. So I'm going to start with the first number, the 1, and I'm going to stick it, or sorry, I just said that backwards. I'm going to take all of the numbers here, the 1, 2, 3, and 6, and I'm going to stick them over one at a time, the numbers in Q. So 1 over 1 is 1, and I can also include the negative. 2 over 1 is 2. 3 over 1 is 3. And 6 over 1 is 6. So start over, take all the numbers in P again, now stick it over the second number in Q. So 1 over 2, 2 over 2, which is 1, well I already listed it, I don't have to do it again. 3 over 2, 6 over 2 is 3, and I've already got it. Okay, start over, take all the numbers in P, and stick it over the third number in Q. So 1 over 4. 2 over 4 is a half, I already have it. 3 over 4. 6 over 4 is 3 over 2. I've already got that one. So these are the possible zeros of that polynomial. So number 5, or example 6, now we want to find the actual zeros of the function. And then once we have them, then we can factor the polynomial. So what this theorem does, like when you list out the possible zeros, these are the numbers that you would try out in the synthetic division to try and get that remainder down to a 0. So So our possible zeros for part 6 or example 6a. The factors of 12, there's a lot of them. 1, 2, 3, 4, 6, and 12. And then the factors of 1 are just 1. So that's kind of nice. When the Q, or the leading coefficient's a 1, and that's really your only choice, it makes your possible zeros list somewhat small. And in fact, it's the same list as the factors of the back number. So 1, 2, 3, 4, 6, and 12. Okay, so we're going to go through synthetic division. And our goal is to pick numbers from this list and have the synthetic division come out with a 0 as the back number. And if it does, then we know we found a factor. If it doesn't, then we know it's not a factor and we have to try again. Okay, so let's just pick, I don't know, let's go with 1. Because it's in the list and I can pick it. Okay, so I'm going to put all my coefficients up there. 1, -2, -11, and 12. And I'm going to run through the synthetic division. So drop the 1. 1 times 1 is 1. -2 plus 1 is -1. -1 times 1, -1. -11 minus 1 is -12. -12 times 1, -12, and 12 minus 12 is 0. So yeah, we got one. So that is your goal. You want that remainder to be a 0. Okay, so let's look at what we have. Your answer, once you divide, is always 1 degree less than what you started with. So if I started with degree 3, this is going to be degree 2. So that's really like 1x squared minus 1x minus 12. So if you can get it to a quadratic, it's usually pretty fast from here because you should be able to factor it. And this one does. X plus 3, x minus 4. So your zeros would be anything that makes the parentheses 0, so -3 and 4, and any number that worked in your synthetic division, which should be the 1. So in a factored form, you'd have x plus 3 times x minus 4 times x minus 1. And the factors can be out of order, like it doesn't matter which one comes first or which one goes last, that's up to you. So if you look at the notes, I have a different order than this, and that's totally fine. All right, let's go ahead and pause here, and then we'll pick it up in the next video.